So let's look at another example of validating an argument using inference rules that involve quantifiers. So here I've written out the argument, Linda, a student in this class, owns a red convertible. Everyone who owns a red convertible has at least one speeding ticket. And you see this everyone right here? That immediately makes me think, I have a universal quantifier somewhere in this argument. And the conclusion of this argument is therefore someone, and that makes me think, an existential quantifier, someone in this class has a speeding ticket. And I want to verify whether or not this is a valid argument. So as usual, the very first thing that I have to do is translate this. So let's start with that. So what are we going to do for our translation step right here? Well, Linda, a student in this class, owns a red convertible, yada, 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 yada. Someone in this class. Okay, so I see this in this class, and it applies both to Linda and someone in this class right here. So that makes me think that I'm going to have a propositional function that represents being a student in this class. So I can go ahead and represent that using a propositional function like the following. C of x is defined to be x is a student in this class. So C for class right here. And the next I see this Linda right here owns a red convertible, but then I also have this universal statement right here that says everyone who owns a red convertible has at least one speeding ticket. So since it applies to both Linda and everyone, that makes me think I'm going to have a propositional function that represents owning a red convertible. So let's go ahead and say R of x is going to be my propositional function. X owns a red convertible right here. And then I have this one last thing. At least one speeding ticket. Someone in this class has a speeding ticket right here. So since this right here has an existential quantifier with this statement and also a universal quantifier with this statement right here, I'm going to have to introduce another propositional function that represents some propositional variable right here having a speeding ticket. So then we can introduce T of x, which represents x has a speeding ticket right here. So now that I've defined my propositional functions right here, I can then translate this English statement into a logical expression. So let's go ahead and do this. Linda, a student in this class. Okay, great. So I know that Linda is a student in this class, so this particular argument has as a hypothesis C of Linda. So Linda is a student in this class. Next, I have that she also owns a red convertible. So Linda owns a red convertible. So that means R of Linda is another hypothesis for this particular argument right here. Linda owns a red convertible. And our last hypothesis, everyone who owns a red convertible has at least one speeding ticket. So this right here involves quantifiers, and this is the claim that everyone who owns a red convertible gets at least one speeding ticket. So if you have a red convertible, then you get a speeding ticket right here. Those are the hypotheses of this argument. And the conclusion of this argument is therefore, someone in this class has a speeding ticket. Therefore, there exists someone who is both in this class and they have a speeding ticket. there exists someone who's in this class and has a speeding ticket using this propositional functions right here. And I want to figure out, is this thing a valid argument? So let's go ahead and justify that this is a valid argument. So our justification is going to proceed as follows. So first off, I see this universal quantifier right here that says for every x, if you have a red convertible, then you have a ticket right here. Well, I know Linda owns a red convertible. So I can use my universal instantiation right here that says if I see a for all x and then some statement, I can stick in any variable I want right there and it's also true. So I know that if these hypotheses right here are true, I can claim the following. I can say R of Linda implies T of Linda. If Linda has a red convertible, then she has at least one speeding ticket right here. And how can I justify this? Well, this universal instantiation right here. This hypothesis says this statement is true for all x. Linda is a particular x, so I can stick that in, and so I can justify this by 1 right here. Great. So that's my first step in my justification. And then I think about it, well, in my hypotheses, I have R of Linda. Well, R of Linda implies T of Linda. So I also know that R of Linda is true because this is one of my hypotheses. And you'll notice that this is again in that same structure of that modus ponens, right? P implies Q and P, therefore I can conclude Q. So if I were to write this down, I could say that my next step is T of Linda is also true. By our modus ponens. The P implies Q, P, therefore Q kind of argument right here. Great. So I also know by hypothesis right here that C of Linda is a true statement because it shows up right here in my hypothesis. So since I have that this is a true statement, this is a true statement, this is a true statement, and so is this, well, hey, check this out. I can conclude that T of Linda and C of Linda. Because both of these right here are true statements. Fantastic. So I have found a particular instance where both C and T are true for some particular variable, Linda in this case right here. And so since I've found a particular example, I can go ahead and use for my table 2 right here, this particular inference rule. If a statement is true for some variable, then we can use our existential quantifier. So I can conclude that indeed this right here is a valid argument. Great. So to recap, what I've done is after my translation, I wrote down what my argument looked like. And then for my justification, what I did is step by step apply all of my different inference rules. So in my very first step, I had to apply one of my quantifier inference rules. And then I just used something by hypothesis. And then I had to use something from my table 1 from a previous section of Rosen up over here. And then I used another hypothesis, and then I went back and I used another inference rule involving quantifiers right here. So as you'll notice, to verify some arguments, basically what it all boils down to is careful application of the different inference rules that we have.